Class 6 Air Atmosphere, ICSE New Simplified. Chemistry by Viraj and Dalal. Solutions Chapter 5, Exercise. Question 1. State what do you understand by the term, air. Explain its importance to mankind. Answer 1. A mixture which occupies space, has mass, and whose composition is differ at places. To pace and time to time is called air. Importance of air to mankind. Air is essential for respiration, living beings, for burning, for tire pressure, for sound propagation. Question 2. Give a brief account of the discovery of air and the scientists involved. Answer. John Mayo. Air has two components, i.e. active and inactive. Lavoisier. Active component of air is oxygen and an inactive component of air is nitrogen. Other scientists discovered noble gases in carbon dioxide, CO2, water vapors. Question 3. What is meant by the term atmosphere? State the role played by the atmosphere for the survival of mankind. Answer. A layer blanket above the earth which spreads like a blanket of air is called atmosphere. Role played by the atmosphere for the survival of mankind. The atmosphere protects us from various harmful gases, and air would not exist without the atmosphere. It also keeps the earth warm at nights and provides gases like carbon dioxide and nitrogen to plants. Question 4. Explain in brief the different layers of the atmosphere and the basic functions of the main layers. Answer. Layers of the atmosphere. Troposphere. Troposphere is the layer just above the Earth's surface whose distance is between 0 to 10 km. It contains most of the air and oxygen, which is essential for all living organisms. This air is used for respiration and other functions. For the survival of human beings. It also forms the weather conditions of the Earth. Stratosphere. Stratosphere is the layer above the troposphere, at a distance between 10 to 50 km above the Earth's surface. It consists of the ozone layer which protects the Earth from ultraviolet rays of the sun. Mesosphere. Mesosphere, the layer above stratosphere at a distance between 50 to 80 km above the Earth's surface. This layer is very cold and burns most of the meteors, preventing them from reaching the Earth's surface. Thermosphere, layer above the mesosphere at a distance between 80 to 320 km above the Earth's surface is thermosphere. Exosphere, topmost layer, is called exosphere. Layers of the atmosphere. Question 5. Describe a simple experiment with the help of a diagram to show that a. Air occupies space. B. Air has mass. C. Air exerts pressure. D. Air is highly compressible. Answer. A. Experiment. 2. Show air occupies space. Procedure. A. Glass bowl is half filled with water. An empty glass tumbler is inverted inside the bowl. When the tumbler is tilted, bubbles are seen in water. Observation. The air was occupying space inside the tumbler, and on tilting air is displaced and bubbles come out because of that. Conclusion. Air occupies space. B. Experiment. 2. Show air has mass. Procedure. An inflated balloon is placed on one side of a simple scale, and the scale tilts towards one side. Air has mass. Observation. The balloon has mass, which makes the scale tilt. Conclusion. Air has mass. C. Experiment. 2. Show air exerts pressure. Procedure. An open can is filled with water and heated. On the formation of steam, the cap is placed tightly such that steam is inside the can. Air exerts pressure. Observation. The steam condenses, and the pressure inside reduces as the steam reduces. The air outside the can exerts pressure and makes the can crumple. Conclusion. Air exerts pressure. D. Experiment. 2. Show air is highly compressible. Procedure. A. Leak. Proof syringe which is empty and filled with air is pushed towards the end. Air is highly compressible. Observation. The piston of the syringe is moved inwards, which implies the air inside the syringe is compressible. Conclusion. Air is highly compressible. Name the components of air with their approximate percentage by volume in air. Does the percentage by volume of each component remain the same in the atmosphere of different parts of the world? Explain with reasons. Answer. Main components of air are nitrogen, oxygen. Composition of air by volume. Nitrogen -78% or 4/5 th. Oxygen 21% or 1/5 th. Carbon dioxide 0.030.04%. Inert gases 0.9%. Air is a mixture whose composition varies at different intervals of time and different places of the world. Question 7. With the help of a labeled diagram, describe a simple experiment to show the presence of oxygen and nitrogen in air using a piece of white phosphorus. Answer. Experiment to show oxygen and nitrogen component in air using a bell jar. Apparatus. A trough, a bell jar, a cork, a crucible and a piece of white phosphorus. Procedure. A trough is filled with a bell jar is labeled into 5 equal parts. A crucible which has white phosphorus is placed on. A cork is floating in the water. The level of water inside the jar and outside the jar are adjusted to one level. The phosphorus is ignited by means of an ignited wire. Observation. The phosphorus burns in air with oxygen and forms dense white fumes of phosphorus pentoxide. The level of water inside the bell jar rises by 1/5 th. Conclusion. Oxygen is the active component in air which burns phosphorus and nitrogen is the inactive component of air which is not used in burning. Question 8. You are given a test tube with 2 outlets and a bottle of lime water. Using the same, how would you demonstrate experimentally the presence of carbon dioxide in air? Answer. Procedure. Lime water is added to the test tube with 2 outlets attached to it. Air is sucked slowly from one outlet. Presence of carbon dioxide in air. Observation. The lime water in the test tube turns milky. Conclusion. Air which is sucked contains carbon dioxide which turns lime water milky. Question 9. Give a reason why water droplets appear on the outer surface of a tumbler containing ice. Answer. Water droplets appear on the outer surface of the beaker. Water vapor condenses on the cooler surface of the beaker, which proves air contains water vapor. Question 10. Explain the importance of nitrogen of the air for plant growth. Answer. Nitrogen is converted into soluble nitrogenous compounds in soil because of air and moisture. These compounds are absorbed by plants and used as proteins. Question 11. Give a reason why nitrogen is filled in food packets and not oxygen. Answer. Nitrogen is an inert and unreactive gas which is filled in food packets to remove oxygen and moisture from them. It keeps the food preserved and fresh by reducing the bacterial growth in the food packages. Question 12. State what would happen if the air above the Earth contained mainly oxygen and no nitrogen. Answer. Nitrogen is utilized by plants for their growth and development. It is converted to soluble nitrogenous compounds in the soil in the presence of air and moisture. They are absorbed by plants and utilized as plant proteins. With no nitrogen, plants will not be able to survive on Earth. Question 13. State the utility of oxygen for respiration in A. Living organisms. B. Plants. Answer. 1. Respiration of living organisms involves inhaling oxygen. 2. Carbon and hydrogen present in food material which forms carbon dioxide, water, vapor and energy in the form of heat. Glucose plus oxygen right pointing arrow. Carbon dioxide plus water vapor plus energy. Two. Plant respiration is the process of plants using up the sugars made through photosynthesis and turning them into energy for growth, reproduction, and other life processes. Plant respiration involves taking in oxygen and releasing it as carbon dioxide into the atmosphere, air. In photosynthesis, solar energy is harvested as chemical energy in a process that converts water and carbon dioxide to glucose. Oxygen is released as a byproduct. In cellular respiration, oxygen is used to break down glucose, releasing chemical energy and heat in the process. Question 14. Compare respiration and combustion both involving oxygen of the air. Answer 14. Respiration is a process whereby living organisms use oxygen from the air to oxidize food substances, mainly glucose, in their body cells, release energy in the form of heat. Carbon dioxide and water vapor are also produced and released in the exhaled air. Respiration is a process whereby living organisms combustion or burning involves oxidation, i.e., combination of substances like fuels with oxygen or air, generally resulting in production of heat and light. Carbon dioxide is released into the air as a result of all burning. Question 15. Explain the importance of carbon dioxide for A. Photosynthesis. B. Warming the Earth's environment. State what would happen if excess carbon dioxide as a pollutant is released into the atmosphere. Answer 15. A. In photosynthesis, green plants manufacture their own food by absorbing carbon dioxide in the air and make food in the presence of chlorophyll and sunlight. Photosynthesis, which occurs during daytime, carbon dioxide and water in the presence of sunlight and chlorophyll is changed into carbohydrates and oxygen. B. In the greenhouse effect, Earth gets heated up because of infrared, visible ray and ultraviolet rays. Carbon dioxide in the air allows UV rays to pass through, but prevents the infrared rays from being radiated out of Earth's surface. It results in warming the Earth's environment. If excess carbon dioxide is released into the atmosphere, it will result in rise in temperature, leading to global warming. Question 16. State in brief how water vapor in the atmosphere determines the climatic conditions. Answer. Water vapor in the atmosphere determines climatic conditions by minimizing the rate at which evaporation takes place, condensation of clouds into rain, and thereby dropping the temperature. Question 17. Give a reason why two different rare inert gases find application in advertisement signs and fluorescent bulbs. Answer. Neon is used in advertisement signs because when current is passed through this gas at low pressure, a brilliant red glow can be seen. This color can be changed by adding mercury and argon. Xenon is used in fluorescent bulbs and lasers because it emits white light in discharge tubes.
Question 18. A mixture has a variable composition. Give 3 other reasons why air is considered a mixture and not a compound. Answer 18. Air is a mixture and not a compound because air does not have a formula like a mixture, while compounds have a fixed formula. When air is formed by gases, there is no energy change. Properties of air are variable and subjective to time and place. Components of air can be physically separated. Question 19. State a reason why there is a balance in the amount of carbon dioxide in the air, even though carbon dioxide is released into the atmosphere by various processes. Answer 19. In photosynthesis, green plants manufacture their own food by absorbing carbon dioxide in the air and make food in the presence of chlorophyll and sunlight. Oxygen is released into the atmosphere, which maintains the composition of air and does not increase the amount of carbon dioxide in air. Question 20. Name 3 different appliances where air is utilized. Answer. Vehicles run on tires, which are inflated with air. Aeroplane fly in air creating heavy pressure difference on wings. Brake mechanisms of trains and other machines work on compressed air. Pumps and siphons work on air pressure. Objective questions. Q.2. The diagrams below represents an experiment to show the presence of a component of air. Question 1. State why air is sucked from outlet B and not from outlet A. Answer. Because if we suck from A, lime water will be sucked out. Question 2. State why the air is sucked slowly from the outlet B. Answer. Because if air is sucked fast, lime water will also be sucked out. Question 3. State the observation seen after completion of the experiment. Answer. Lime water turns milky. Question 4. State the reason for the above observation seen. Answer. The reason is the formation of CO2. Question 5. Name another component which if present in air as a pollutant would have given a similar observation. Answer. Sulfur dioxide. Q.3. Complete the statements given below by filling in the blanks with the correct word S from the word S in bracket. Question 1. The ____ atmosphere, troposphere, stratosphere as a layer which extends up to about 10 to 50 kms above the Earth. Answer. The stratosphere is a layer which extends up to about 10 to 50 kms above the Earth. Question 2. Helium hydrogen sulfide is an example of a pollutant present in air. Answer. Hydrogen sulfide is an example of a pollutant present in air. Question 3. The component of air used in photosynthesis is and the products of photosynthesis is oxygen, carbon dioxide, nitrogen. Answer. The component of air used in photosynthesis is carbon dioxide and the products of photosynthesis is oxygen. Question 4. The product formed, which is common to both combustion and respiration is oxygen, carbon dioxide, nitrogen dioxide. Answer. The product formed, which is common to both combustion and respiration is nitrogen dioxide. Question 5. The component of air, which is variable in air above sea level and in air in general oxygen, nitrogen, water, vapor. Answer. The component of air, which is variable in air above sea level and in air in general water, vapor. Q.4. Name the following. Question 1. The product formed when phosphorus burns in oxygen. Answer. Phosphorus pentoxide, P2O5. Question 2. The layer of atmosphere, which contains the ozone layer. Answer. Stratosphere. Question 3. The active component of air which supports combustion and is used up in burning. Answer. Oxygen. Question 4. The main, rare, inert gas present in air. Answer. Argon. Question 5. The component of air, which is present more in industrial areas. Answer. Carbon monoxide, sulfur dioxide, oxides of nitrogen, hydrogen, sulfide, dust particles. Question 6. The type of bacteria, which directly absorb nitrogen from the air, and converted soluble nitrates in the soil. Answer. Symbiotic bacteria. Question 7. The product of respiration released in exhaled AJR, other than carbon dioxide. Answer. Water vapor and energy. Question 8. An inert gas which has a low boiling point and is used for producing very low temperatures. Answer. Helium. Question 9. A process which removes carbon dioxide from the air. Answer. Photosynthesis. Question 10. The component of air, which does not support combustion. Answer. Nitrogen. Q.5. State whether the following statements are true or false. If false, write the correct statement. 1. The mesosphere in the atmosphere contains most of the air fit for respiration. Ans. False. Correct. The troposphere in the atmosphere contains most of the air fit for respiration. 2. The percentage of carbon dioxide in the air is between 0.2 to 0.4%. Ans. True. 3. Carbon dioxide, water vapor and energy in the form of heat are evolved during respiration. Ans. True. 4. Photosynthesis is a process by which green plants prepare their own food in the presence of sunlight and chlorophyll. Ans. True. 5. Air is a mixture and not a compound since the components of air cannot be separated by physical methods. Ands. False. Correct. Air is a mixture and not a compound, since the components of air can be separated by physical methods. Q.6. Give word equations for the following conversions. Question 1. Nitrogen of the air to nitric oxide. Answer. The nitric oxide reacts with oxygen to give nitrogen dioxide. Question 2. Nitric oxide to nitrogen dioxide. Answer. Nitric oxide plus oxygen. Right pointing arrow, nitrogen dioxide. The nitrogen dioxide further reacts with oxygen and water vapor of the air to give nitric acid. Question 3. Nitrogen dioxide to Q.6. Give word equations for the following conversions. Question 1. Nitrogen of the air to nitric oxide. Answer. The nitric oxide reacts with oxygen to give nitrogen dioxide. Question 2. Nitric oxide to nitrogen dioxide. Answer. Nitric oxide plus oxygen. Right pointing arrow, nitrogen dioxide. The nitrogen dioxide further reacts with oxygen and water vapor of the air to give nitric acid. Question 3. Nitrogen dioxide to nitric acid. Answer. Nitrogen dioxide plus oxygen plus water. Right pointing arrow, nitric acid. The nitric acid formed comes down with the rain and combines with the carbonates in the soil to form soluble nitrates. Question 4. Nitric acid to soluble nitrates in the soil. Answer. Calcium carbonate plus nitric acid, right pointing arrow. Calcium nitrate plus water plus carbon dioxide. The water-soluble calcium nitrates are absorbed by the plants and converted to plant proteins. Question 5. Carbon dioxide in air to carbohydrates in plants. Answer. Carbon dioxide and water in the presence of sunlight and chlorophyll is changed into carbohydrate, and oxygen is released out.